Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of the solids. I am Dr. A.I.P. Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a square prism having height of the axis equal to 90 millimeter, and this square prism happens to be resting onto its square base in the horizontal plane. And the orientation of the square prism with respect to the two planes is such that the edges of the base, they are equally inclined with respect to the vertical plane. So we cannot choose this orientation of the square prism onto the horizontal plane because over here all the faces, they are not equally inclined to the vertical plane. The two edges of the base, they are parallel to VP, while other two edges of the base, they happen to be perpendicular to VP. So whereas if we choose this orientation of the square prism onto the horizontal plane, now all the four edges of the square prism, they will be inclined at an angle of 45 degrees with respect to the vertical plane. So this is the correct orientation of the square prism onto the horizontal plane. So here we have got the bottom face of the prism 1, 2, 3, 4, and the top face has been represented as A, B, C and D over here. Now we have been provided with the information that this square prism has been cut by an auxiliary inclined plane which is passing through the midpoint of the axis over here. So if we draw the midpoint of the axis, so through the midpoint of the axis, the cutting plane AIP, that is the auxiliary inclined plane, should be intersecting with the square prism. But in this case, we have not been provided with the angle of orientation of this auxiliary inclined plane with respect to the horizontal plane. So how do we locate the orientation of this auxiliary inclined plane? So here we have been provided with the true shape of the cut section which will be obtained after the intersection of this cutting plane with the square prism over here. Now we have been provided with the information that the true shape of the cut section, it happens to be a rhombus having diagonals 80 millimeter and 40 millimeter over here. Now the two diagonals which are mutually perpendicular to each other corresponding to the true shape of the rhombus. So the dimensions of these two diagonals, they have been provided to us as 80 millimeter. It is the dimension of the longer diagonal. 40 millimeter happens to be the dimension of the shorter diagonal. Now we are required to draw the projections of the sectioned front view and the top view, and we are also required to determine the inclination of the auxiliary inclined plane with respect to the horizontal plane. Now here we can check another thing, that even the edge of the base, it has also not been provided over here. So we have got two missing informations into this particular problem. First is the orientation of the auxiliary inclined plane or the cutting plane with respect to HB has not been provided, and the edge of the base has also not been provided over here. Now how do we obtain the true shape of the cut section as a rhombus having diagonals 80 millimeter and 40 millimeter over here? So within this we have been provided with the information to obtain the orientation of the AIP, and even the edge of the base we can locate using this information over here. Now how we can process this true shape rhombus diagonal dimensions information over here in order to obtain the orientation of this cutting plane and the edge of the base? Now we need to understand one thing over here, that since this rhombus will be obtained as a true shape which will be drawn parallel to this auxiliary inclined plane, so one thing is very much evident, since this cutting plane will be parallel to the auxiliary inclined plane onto which this rhombus shape will be obtained, into which longer dimension of the diagonal of the rhombus will be equal to 80 millimeter. That is, this longer dimension 80 millimeter will be available over here. So now one thing we have been able to identify through this information, that the longer edge, it will be parallel to the cutting plane over here. And we also know that these are two access points. So O and O1 over here. So through the midpoint of the axis, the cutting plane or the auxiliary inclined plane should be passing. And now in order to obtain the true shape of the cut section as the rhombus, the square prism should be intersected by the cutting plane at minimum of 4 points over here. So one point will be onto A1, another point will be lying on B2, third point will be lying on C3, and fourth point of intersection will be lying onto the vertical edge D4 over here. So now since we know that this dimension of the longer edge, it is equal to 80 millimeter, so the 2 points of intersection we can locate on the vertical edges A1 and C3 such that the distance of these 2 points of intersection from the midpoint of the axis, you see, from point O and O1. So this is the midpoint. So from the midpoint, this length should be equal to 40 millimeter and this length should also be equal to 40 millimeter. So once we are able to identify the midpoint in the front view projections, then using this midpoint as the center point, we are going to mark 2 arcs onto the extreme vertical edges over here, A1 and C3 over here, such that the distance from point M to first point of intersection available onto the vertical edge A1, it should be 40 millimeter. Similarly, distance of the point M and the second point of intersection available onto the vertical edge C3. So this distance should also be 40 millimeter. So with this information, the orientation of the auxiliary inclined plane in the front view projections we will be able to identify. So one of the missing links which was there in the given problem has been addressed over here. Now second missing link in the problem is edge of the square base over here. So this edge of the square base has not been provided to us. So how do we evaluate this edge of the square base? Now we can check. If we draw the top view projections of the square prism into this orientation, then while we draw the auxiliary plane projections onto this auxiliary inclined plane which will be drawn parallel to this cutting plane, now the minor diagonal of the rhombus will be perpendicular to the major diagonal, and we know that this dimension of the minor diagonal happens to be 40 millimeter. Now this distance 40 millimeter will be corresponding to the diagonal of the square over here. That is, indirectly we have not been provided with the edge of this particular square base of the square prism. Rather, we have been provided with the distance between these 2 points over here, which will be appearing as minor diagonal onto the rhombus which will be available with us into the auxiliary plane projections which are obtained on AIP drawn parallel to this cutting plane. So this minor diagonal of 40 millimeter will mean that these 2 points which are available onto the minor diagonal, so these 2 points, they are separated by the distance equal to 40 millimeter. So this distance will correspond to the distance between these 2 diagonal points of the square base of the prism over here. So this way we have to draw the square prism base in such a way that the diagonal dimension we have to take as 40 millimeter. So this way the second missing link of this problem has also been resolved over here. So with this information, now let us proceed with the evaluation of orthographic projections of the square prism which is lying onto the horizontal plane on one of its square faces, such that all the 4 edges of the square prism, they happen to be equally inclined to the vertical plane. Now, as we have discussed, we have not been provided with this dimension, that is the edge of the base. Rather, because we have been provided with the information that the minor diagonal of the rhombus corresponding to the cut section, it will be measuring 40 millimeter. So now, corresponding to the true shape of the rhombus which we are going to obtain over here onto the AIP, which will be drawn parallel to the cutting plane. Now, this minor diagonal dimension of 40 millimeter will be corresponding to these two corners of the square prism base over here. So this way, now since we have been provided with this information that the diagonal BD and diagonal AC, similarly the diagonals 2, 4 and 1, 3, they happen to be equal to 40 millimeter. So using this information, now we can check. We have drawn a circular projection of 40 millimeter diameter over here. Now, having drawn this circular projection, now we will be locating the horizontal diameter and the vertical diameter corresponding to this circular projection, which is going to represent the diagonal of the square prism over here. Now, we have been able to obtain 4 points, and through these 4 points, the base of the square prism should be passing out over here. Now we can join the 4 points over here which are available onto the base. So let us mark these 4 points. So the 4 points of the top face we have marked as A, B, C, D on the outer side of the projections of the square prism, and the 4 points corresponding to the base we have marked as 1, 2, 3 and 4 over here. So this way, using the information that the minor diagonal of the cut section is having the dimension 40 millimeter, now we have got this diagonal of the square equal to 40 millimeter. So corresponding to this, we have been able to obtain the projections of the square prism in which all the 4 edges of the base, they are inclined at an equal angle of 45 degree with respect to the vertical plane. Now we have obtained the top view projections. Now let us obtain the axis point of the square prism in the top view projections over here. So here we get axis points as O and O1. So O point of the axis, it happens to lie corresponding to the top face of the solid, and the O1 point happens to lie corresponding to the base onto the horizontal plane over here. So here we have got 2 points of the axis O and O1 represented in the top view projections. Now we know that the height of the square prism happens to be 90 millimeter. So now we can mark the axis height is equal to 90 millimeter over here. So now once we mark the axis height is equal to 90 millimeter, so the front view projections of the square prism we can obtain. So point A, it will be projected as point A dash. Points B and D, they will be projected as B dash and D dash. And point C corresponding to the top face will be represented as point C dash onto the front view projections over here. So we can check all the 4 points A dash, B dash, C dash and D dash. They have been obtained at a height of 90 millimeter from the XY reference line. So these points represent the projections of the top face of the square prism. Similarly, corresponding to the base, point 1 has been projected as point 1 dash onto the XY reference line. Points 2 and 4, they have been projected as 2 dash and 4 dash onto the XY reference line. And point 3 has been projected as point 3 dash onto the XY reference line. Now let us locate the axis points. So as we have discussed, point O, it is the axis point corresponding to the top face of the solid. We have got projections of point O projected as point O dash onto the top face into the front view projections over here. Similarly, point O1 dash happens to lie onto the XY reference line because point O1 is the axis point corresponding to the base of the square prism over here. Now we have got the information that the prism has been intersected by an auxiliary inclined plane passing through the midpoint of the axis. Now here we can see this is point O, axis point of the top face. This is point O1, axis point of the bottom face or the base. Now this is the axis OO1. Now once we find out the axis midpoint over here, so here we have got the midpoint of the axis OO1. Now through this point the cutting plane is passing. Now we also know that the cutting plane should be intersecting with all the vertical edges of the square prism. Now we know that the dimension of the major diagonal of the rhombus, which will be representing the true shape of the cut section, this is going to measure 80 millimeter. So now we know that if we have to obtain the true shape of the cut section, we have to draw an auxiliary inclined plane parallel to this cutting plane, and whatever true shape of the cut section will be obtained, onto the true shape the longer edge will be measuring, the longer edge or the longer diagonal of this rhombus will be measuring 80 millimeter. So if the longer diagonal of this rhombus is going to measure 80 millimeter, then this auxiliary inclined plane, as it is oriented into this position, it should also be measuring 80 millimeter between the vertical edges A1 and C3 over here. So now we have to locate the orientation of this cutting plane into the front view projections in such a way that through this midpoint, this length of the midpoint and the first point of intersection, which will be obtained on the vertical edge A1, this distance between these 2 points should be equal to 40 millimeter. Similarly, now the distance of the point which is obtained over here, that is the midpoint on the axis, and the second point of intersection which will be obtained onto the vertical edge C3. So this point, so distance between this point of intersection and the midpoint of the axis, it should also be 40 millimeter. So now what we have to do? Now we have to locate the midpoint of the axis in the front view projections. We know that this is the axis which has been represented as 90 millimeter height into the front view projections over here. So O', distance happens to be 90 millimeter. Now let us locate the midpoint of the axis over here. So once we locate the midpoint of the axis, now we have to draw two arcs from this particular point onto the vertical edges A', and C', such that this cutting plane which we are going to locate over here into the front view projections, it should be located in such a manner that the distance between this point and the first point of intersection obtained on A', it should be 40 millimeter. Similarly, the distance of this midpoint and the second point of intersection obtained on the vertical edge C', so this distance should also be equal to 40 millimeter. So now we can check. We have marked two arcs over here with this point as the center, midpoint as the center. We'll open the arc is equal to 40 millimeter. So we'll mark one arc on A', we'll mark second arc onto the vertical edge C', such that the radius of this arc should be equal to 40 millimeter. So now we can see we have been able to locate the orientation of the auxiliary inclined plane or the cutting plane with respect to the horizontal plane. So we can measure this angle of inclination of the cutting plane with respect to the horizontal plane, and this cutting plane happens to be perpendicular to the vertical plane and inclined to the horizontal plane. Now this distance from first point of intersection to second point of intersection will be equal to 80 millimeter, which will be represented as a major diagonal onto the auxiliary plan projection view over here, onto the AIP, which will be drawn parallel to this cutting plane. Let us locate these 4 points which will be obtained onto the 4 vertical edges of the square prism into the front view projections over here. So we can check A dash 1 dash vertical edge of the square prism has been intersected by the cutting plane at point 11 dash over here. Since this point 11 dash happens to lie onto the vertical edge A dash 1 dash, so if we are going to look at this point of intersection from the top, so 11 dash, A dash and 1 dash, they lie onto the same vertical edge over here. So 11, A and 1, these 3 points, they are going to coincide with each other in the top view projections. So we are going to obtain point 11 alongside the points A and 1 in the top view projections over here. Now the next point of intersection is point 12 dash. So point 12 dash, it is the point of intersection of the cutting plane with the vertical edge of the square prism B dash 2 dash. That is, it is this edge. B dash 2 dash vertical edge will be intersected by the cutting plane at the point 12 dash over here. Now 12 point lies over here. So point 12, B and 2, they are going to lie onto the same vertical projector line. Now if we are going to look at this edge from the top, so the points B, 12 and 2, they will be located onto the same point. They will be coinciding with each other. So point 12, that is the second point of intersection 12, has been appropriately located in the top view projections over here. Third point of intersection of the cutting plane with the vertical edge C dash 3 dash happens to be 13 dash over here. Now since C dash, 13 dash and 3 dash, it is this point, 13 point over here. So C, 13 and 3, all of these 3 points, they happen to lie onto the vertical edge which is perpendicular to HP. So in the top view projections, points C, 3 and 13, they will be coinciding with each other. So we have been able to locate third point of intersection, that is point 13, into the top view projections over here. And finally, the fourth point of intersection of the cutting plane with the vertical edge, we can check D4. So edge D4 has been cut by the cutting plane at the point 14 dash over here. So the edge D dash 4 dash has been intersected by this cutting plane at the point 14 dash. Now since points D, 14 and 4, they are going to lie onto the same vertical edge perpendicular to HP. So in the top view projections, we are going to have coincidence of points D, 4 and 14 in the top view projections over here. So this way, all the 4 points of intersection have been obtained into the front view projections and they have been located appropriately into the top view projections over here. So now we will see that this portion of the square prism has been removed as it has been sectioned by the cutting plane or the auxiliary inclined plane, which happens to be perpendicular to VP and inclined to HP at this angle over here. Now let us evaluate the remainder solid. So the remainder solid has been marked with the help of blue object lines over here. So whereas this portion of the solid is no longer available with us. Similarly, in the top view, let us obtain the projections of the uncut solid. So the uncut solid will be A, B, C, D. Similarly, and the section top view will be obtained by joining the points 11, 12, 13 and 14. And since we have witnessed that point 11 will be coinciding with A1, point 12 will be coinciding with B2, point 13 has coincided with C3 and point 14 has coincided with D4. So the top view projections of the cut solid and the section solid projections, they have overlapped with each other into the top view projections over here. So this way we have been able to obtain the sectional top view projections corresponding to this cut section. Now one thing we must understand over here, since this cut section is obtained inclined with respect to horizontal plane, because the cutting plane or the auxiliary inclined plane happen to be inclined to the horizontal plane. So the sectional top view projections that we have obtained in the plan projection view, they represent apparent shape projections of this section solid. So now we need to obtain true shape projections of the cut section over here. So here we have got 4 points corresponding to the cut section. So which are these 4 points? 11 dash, 12 dash, 13 dash and 14 dash points over here. Now with respect to this auxiliary inclined plane or the cutting plane, now we have to obtain the projections of these 4 points onto an auxiliary inclined plane x1, y1, which has been drawn parallel to this cutting plane over here. So the cutting plane orientation we have already identified. So with respect to this cutting plane, we have drawn an AIP x1, y1 parallel to this cutting plane. Now from the 4 points of the cut section, now we need to draw perpendicular projectors onto the AIP x1, y1 over here. And now the auxiliary plan projections which we are going to obtain now onto the AIP x1, y1, they will be providing us with the true shape projections of the cut section, because the AIP x1, y1 happens to be parallel to this cut section. So now let us evaluate the locations of the points 11, 12, 13, 14 onto this auxiliary inclined plane. Now first point available with us is point 11. Now we have measured the distance between point 11 and the XY reference line. So this distance we have measured. Now onto the projector line emerging through the point 11 dash, same distance of the point 11 from the XY reference plane will be marked ahead of this auxiliary inclined plane. So the same distance we have marked it out over here. So this will provide us with the location of the point 11, 1 into the auxiliary plan projection view over here. Now the next point which is available with us, it is point number 12 over here. So we are going to measure the distance of the point 12 from the XY reference line. So this is the distance of the point 12 from the XY reference line. Now corresponding to the point 12 dash onto this projector line, we are going to mark the same distance ahead of the plane over here. So this point which we are going to obtain by marking this distance, which is equal to the distance of point 12 from the XY reference line. So we will be obtaining the point 12, 1 in the plan projection view. Now the next point available with us, it is point number 14 over here. So we know that this is the distance of point 14 from the XY reference line. So from the projector which is originating from 14 dash, now we have marked the same distance ahead of the auxiliary inclined plane x1, y1, which is going to yield the point 14, 1 in the plan projection view over here. So again we can check distance of point 14 from XY reference plane. It is equal to distance of point 14, 1 from the x1, y1 AIP over here. So the third point of intersection in the auxiliary plan projection view has been appropriately located. Now the last point available over here is point 13. Now we are going to measure the distance of point 13 from the XY reference line. Now from the projector line emerging from the point 13 dash, the same distance we are going to mark ahead of the plane x1, y1 over here. So this way we have been able to evaluate the location of the point 13, 1 in the plan projection view. Now we can check if we join the points 11, 1, 12, 1, 13, 1 and 14, 1, we are going to obtain the rhombus shaped projections as true shape projections which are obtained corresponding to this cut section over here. And another thing we need to observe over here, that the distance between 11, 1 and 13, 1 will be equal to distance between the points 11 dash and 13 dash over here. So this is also going to represent the true length of the major diagonal of the rhombus over here. So that is why we had marked distance between 11 dash and 12 dash as 40 millimeter. Distance between 12 dash and 13 dash we had also marked as 40 millimeter. So the distance between 11.1 and 13.1, it represents the true length of the major diagonal. It is equal to 80 millimeter. And the distance between 12.1 and 14.1. So please check. Distance between 12.1 and 14.1, it is equal to this distance. That is distance between points 2 and 4 or distance between the points B and D, which is equal to 40 millimeter. So now we can see distance between 12.1 and 14.1, it is equal to 40 millimeter. Distance between 11.1 and 13.1 happens to be 80 millimeter. So this way we have been able to obtain the rhombus shape projections as true shape projections of the cut section. So that is how we have been able to evaluate the edge length of the square prism. We have been able to evaluate the angle of orientation or inclination of this cutting plane with respect to the horizontal plane, and we have also evaluated the sectional front view projections, the sectional top view projections, and we have also evaluated the true shape projections of the cut section corresponding to an AIP intersecting with midpoint of the axis of the square prism, and this AIP happens to be inclined with respect to HP at a certain angle of inclination, so which we have evaluated over here. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate sectional front view projections, sectional top view projections, and true shape of the cut section when the square prism has been intersected by an auxiliary inclined plane such that the true shape of the cut section projections, they happen to be rhombus having dimensions 40 millimeter minor diagonal and 80 millimeter major diagonal. So we will be continuing with further discussion regarding few more illustrative cases of section of the solids in the coming lectures. So thank you very much. Thanks a lot.